Hello everybody, welcome to this video on understanding process analyses and figuring out how you evaluate processes. We'll mainly be talking about process capacity in this video. What is process capacity? How do you evaluate it? What are the different ways of coming about it? What do you do when you have a single flow unit? What do you do when you have multiple flow units? We'll talk about all of that in this video. So before beginning, here are the basic concepts within process analysis that we need. So we talked about a few of these in the previous video. Let's talk about some more of them right here. So inventory, that's the number of flow units in the system. So that's the inventory that you have. Activity times, how long does it take for a particular task to get done? Then you have capacity, which is 1 divided by activity time. So it tells you how many of these activities can be done within a given amount of time. Then you need something called the bottleneck. Now we'll talk about the bottleneck a little bit more later on, but it's just the step in the process which has the lowest capacity. We know what flow rate is. We'll talk about utilization, which is flow rate divided by capacity. And of course, we know what flow time is. Now, some of these things we know, some of these things we don't. We will define most or more of them as we go through this process. Okay, so let's begin with how do you analyze processes? Now, the first thing that you always do is you draw a process flow diagram. Now, when you're drawing a process flow diagram, there are three main things that you keep track of. You either draw a box, a triangle, or an arrow. So boxes stand for actual activities within the process. Triangles represent either waiting areas or buffers which hold some sort of inventory. And finally, arrows show the direction in which the process is going to flow. So here is an example of a hot dog making process. You have meat, you have all sorts of meat that goes in. There is a process that grinds all the trimmings in, and then you put them. So you see a buffer here which says that once you grind all the trimmings in, you put them in inventory location. So this is not a conveyor belt that goes directly from grind trimmings to mixing ingredients. So you finish grinding trimmings and somebody carries them, or a machine carries them, let's say in a wheelbarrow, to a place where the ingredients actually get mixed, right? Then all the different ingredients get mixed. The mixed ingredients are placed in a buffer, and then there is stuffing. You stuff all the ingredients in to a particular shape. And once you do all of that, they are put on trays, and then they go into ovens where you cook and you flavor them. And once you come back, you peel them. Then there is inspection, and finally we have hot dogs that come out of the factory. So this is the process of making hot dogs. So you'll notice there are arrows pointing in the direction of where in which the flow unit is going to flow. The rectangles or the squares represent, in this case they're definitely rectangles, they represent the different stages in the process. The intermediate locations, the triangles in the intermediate locations are buffers. Now, there's not always a buffer between stages that are one right after the other, but in this case there are. So it is important to know when you have buffers and when you don't. So here is the data for this process. So you have two grinding machines. 22,000 hot dogs dogs are ground per batch, and 5 minutes to ground a load and to make them into a grid. And then you have 6 mixers that mix everything. So 22,000 dogs per batch in this, and it takes half an hour to mix, and you have 3 machines. And then you have in the cooking and flavoring. So you have 5 ovens that you use to cook. Each oven holds 15,000 hot dogs, and it's 15 minutes to process each hot dog through that oven. Then the peeler, you have 700 hot dogs per minute per peeler. Then you have 8 peeling machines right here. So that's the peeling portion. Once they are done, they're put on a tray, put into packages, and finally you have inspection. So each inspector requires 1/6 of a second to inspect each hot dog. So basically just eyeball it, right? And they eyeball multiple hot dogs at once. And you have 17 such inspection stations. And this is the kind of data that you get, right? Now, in this process, it is important to know how many hot dogs can this process make let's say in an hour. What is the capacity of this process in an hour, in a minute, however you want? We'll talk about it in a minute in the beginning, and then we'll move on to hour. But that's the idea that we want to figure out. And we also want to figure out, you have all of these different processes, which is the slowest one, which is the bottleneck process. That's the one that we're going to figure out. To do all of this, we need to calculate capacity. So let's see how capacity is calculated, right? So here is an example of how you calculate it for the first three portions: the grinding, mixing, and the stuffing. So we know that for the grinding process, you choose any time length that you want. In this case, we'll choose per minute, like I said. So for the grinding, each grinder, we were given that information here. It takes 5 minutes to load and grind each hot dog. And there are 22,000 hot dogs that go through this process in a batch. So each grinder can grind 4,400 hot dogs per minute. How did I get that? So 22,000 hot dogs divided by 5 minutes. So it takes 5 minutes for the whole process to go through. So the flow rate, you could calculate it. So it's 4,400. That's the capacity of the hot dogs. But this is the capacity of each grinder, and we know that there are two grinding machines available. So there are two grinders. And so the capacity of the grinding process. So the capacity of the grinding process is 8,800 hot dogs per minute. So this is the average value, right? Obviously, it takes 5 minutes for the process to happen. So one hot dog has to wait 5 minutes for the process to happen. But we are just averaging these numbers out, and we say that the average capacity for the grinder is, for the grinding process, is 8,800 hot dogs. Now, let's look at the mixer. The mixing process, again, it's 22,000 hot dogs that go through the process. Now, each mixture, it takes 1/3 of an hour for the mixer to go through. Now, because we are calculating everything in minutes, 1/3 of an hour is basically 20 minutes, right? So it's 1,100, obviously. So it's 2,200 divided by 20 minutes. That gives us 1,100 hot dogs per minute. And we know that there are 6 mixers. And so 6 times 1,100, which is 6,600 hot dogs per minute. And that's the capacity. So we already see that the grinding machine can grind a lot more than the lot faster than the mixing machines can do. So if you just let the grinding and mixing process go through, the inventory in this buffer will keep building up over and over a period of time if you just let them go at their full capacity. But that's not what you do, right? So you look at the demand that you have. Maybe you don't need so many hot dogs in 1 minute because the demand that you have is lower. So there are lots of different things that come into play. But the grind trimming process is a higher capacity. This is 8,800, while this is only 6,600. Now let's look at the third one, which is stuffing. Next page. So there are 3 stuffers, and each stuffing machine can make 2,300 hot dogs per minute. How do we know that? That's the data that's given. It's 2,300 hot dogs per minute per machine, and we know that each of them takes half an hour to mix, and 3 machines and so on. So with all of that, we can calculate that the stuffing process, the capacity of the stuffing process is 6,900 hot dogs per minute. Okay. Now, once we have that, now let's look at the cooking and flavoring process. The cooking and flavoring process has 5 ovens. Each oven holds 15,000 hot dogs, and it takes 15 minutes for it to go through the process. So that's the process time. So it's the flow time. This is the inventory. So we can calculate the flow rate, which is what we want. 15,000 divided by 15, which is 1,000, right? Yes, 1,000 hot dogs per minute. And there are 5 ovens. So the capacity of this process is 5 hot dogs per minute. So similarly with peelers, the capacity is 5,600 and inspection is 6,120. How do we know that? There are 17 stations, and each person can inspect 6 hot dogs in a minute because it's 1/6 second per hot dog. So 6 hot dogs in a minute. So times 60 seconds. So that gives you 6,120 hot dogs per minute. So what we did was we went through each of these 6 steps in the process, and we calculated the capacity per process. So when you calculate capacity, it's the flow rate that you calculate based on some unit of time. In this case, we chose minute. It didn't have to be a minute. We could have calculated per hour, but we calculated it as per minute. And these are the numbers that we ended up with, right? So the grinding process had a capacity of 8800, mixing process 6600, stuffing process 6900. The bottleneck is the flavoring process, which can only do the cooking process, which is 5000 dogs per minute. Peeler is 5600 and inspection is 6120. And that's the bottleneck, but because that has the least capacity. All the other machines have to wait for this particular machine. So even the grinding machine will only make 5000 hot dogs in a minute, only because if they made more, then the whole process would basically grind to a halt. Or you just have a lot of work in process inventory left over. And because this is perishable goods, you don't want work in process inventory left over there. So the flow rate for this process, once you look at all of these different flow rates, you choose the one that's the lowest, and that's the flow rate for the whole process. So flow rate for this process is 5000 hot dogs per minute. This process can also produce 5000 hot dogs per minute times, so which is about 300,000 hot dogs per hour, if you look at it as per hour, right? Okay, so with that, the next thing that we need to calculate is the implied utilization. So implied utilization is something that is important to understand. So once we know what the capacities are, we can calculate implied utilization as demand divided by capacity. So what does that mean? Say for example, here with this process, we know that we can make 5000 hot dogs a minute or 300,000 hot dogs an hour. So if let's say that this machine works for 8 hours a day. So if it's 300,000 hot dogs an hour and the process works for 8 hours a day, that is 2,400,000 hot dogs a day. That's the capacity that it can have. So that's how many hot dogs it can make. But let's say that based upon the data that you have, you know that your demand is only 2 million hot dogs an hour a day. Instead of the capacity is 2.4 million hot dogs a day, but the demand is only for 2 million hot dogs a day, then your implied utilization will be 2 divided by 2.4, which will give you something along the lines of 20 divided by 24, which is 56, right? So but 87.77 something. So that's the implied utilization. So sorry, 91.66%. I think. Yeah. So that's the implied utilization there. Now we can calculate the implied utilization for every stage individually. So in this case, the whole process has a flow rate of 5000, but each individual stage has a different flow rate. Now let's say the demand for us is 4000 hot dogs a minute. So if you calculate demand and it comes down to 4,000 hot dogs a minute, it means that even though your process can produce 5,000 hot dogs a minute, you don't need to produce 5,000 hot dogs a minute. And implied utilization is, demand divided by capacity. That's the implied utilization. So if demand is only 4,000 hot dogs a minute, then the implied utilization for the whole process will be 4,000 divided by 5,000, because 5,000 is the capacity. So 4,000 divided by 5,000, which is 80%. So the whole process will run at 80% capacity, but each individual stage in the process has different capacities. Say for example, different implied utilization. So if demand is only 4,000 hot dogs a minute, then the grind trimmings process has a implied utilization of 4,000 divided by 8,800, which is much less than for the whole process, which is 4,000 divided by 5,000. So each individual stage has its own implied utilization. It's good to know what the implied utilizations are so you can compare them against each other. It's just, again, a different metric giving you the same answer basically. Now, before I end the video here, let me quickly talk about what happens when you have different types of flow units, right? And this is a simple example. So let's say that there are 3 types of job applications that you have to look at. So you're a company that looks at job applications. So you're looking at three different types of job applications. One is for consulting, so where you contact some faculty, then you contact prior employers, and then you give out a decision letter. If it's a staff position, you just contact the prior employers and then you give out a decision letter. And if it's an internship, you look at the grades that the student has and then you give out a decision letter based purely on the benchmark grades that you have. So each type of application has its own process and does not necessarily involve all three tasks. The only one consulting job, that's the only one that involves all, so these three tasks, but it doesn't involve, say, looking at benchmark grade, right? So in a situation like this, when you have multiple flow units, how do you do process analysis? It is obviously a lot more complicated than what you had before. So the way you do it is you define a common flow unit so that the capacity of each task can be expressed in terms of that flow unit per time. And demand can also be expressed as in terms of that particular flow unit. So an intuitive flow unit in this case would be, say, an application. It could be an application, any type of application. You have three different types of application, but it's still an application, right? So given that an application is the flow unit, the capacity of each task should be defined in terms of an application per unit time, right? So let's get some data here. So this is the data that's given to us. So the number of applications that come in per hour for consulting are 3. Number of applications for staff is 11. And number of applications for internship is, let's say, 4. Now, the data that's given to us is there are 2 people allowed to us who can contact employees, 3 people out there contacting employers, 2 people looking at benchmark gates, and 1 person basically going through the... these are the number of workers, I'm sorry. These are the number of workers who are looking at each of these different things. And this is the time that you have per for each of these processes, right? So capacity per worker, so you calculate that as 1 over B. So this is basically the 1 divided by capacity. So 1 divided by 20 will give you 0.05, right? And the task total capacity is the 0.05 times 2 because that's how many you can do in a minute. So that's basically what you're looking at here. So you can calculate 2 faculty within a minute. You can calculate 3 employers in a minute. You can benchmark 2 grades in a minute, and you can make out 1 decision letter per minute, right? So with that, you can calculate the task's capacity, and you can as the number of applications per minute. So this will be 1 divided by 20, which gives you 0.05 times 2, which will give you 0.1. 1 divided by 15 will give you 0.07 times 3 will give you 0.2. It should be 0.21, but then there's some rounding errors here and there. So just remember that. So this 1 divided by 8, which will be not 13, it's actually 0.125. Multiply that with 2 will give you 0.25, right? And finally, you can calculate the capacity per hour by just multiplying this number by 6. Right, so the capacity per hour is you can calculate 6 faculty in an hour, you can calculate 12 employers in an hour, you can benchmark 15 grades in an hour, and you can give out 30 decision letters in an hour. Right, so that's basically what you can do here. So with that information, we can now calculate implied utilization for each of these different parts of the processes, different stages of the process. So contacting faculty, so with that we can calculate that so the task capacity is 6 per hour, right? So task capacity is 6 per hour, so implied utilization is 50% because let's say the demand is only 3 per hour. How do we know that demand is 3 per hour? Because that's the number of applications that come in per hour. So consulting is 3, staffing is 11, and internship is 4. And if you look at here, consulting, contacting faculty is only for consulting jobs. Contacting prior employers is for both consulting and staff jobs. Benchmarking grades is only for internship, but decision letter is for all 3 types of jobs, right? So because that's the case, the demand is only 3 here. So if you look at the demand for decision letter, it says 18. How did I get the number 18? That is 11 plus 3 plus 4. So all of these applications have to go through the decision letter stage of the process. So you have 18 applications going through the decision letter stage of the process. For contacting faculty is only 3 because it's consulting only. Contacting employers is both consulting and staff, so it will be 14. Benchmarking grades will only be internship, which is 4, and decision letter will be all 3, which will be 18. And that's the numbers that you see here: 6, 3, 14, 4, and 18. Right. So this is the demand per hour, and this is the task's capacity per hour. So you'll notice that the contacting faculty capacity is 50%. But the contacting employers capacity is 117%. This actually, we don't have enough capacity to, based upon the average values that we calculated. Benchmarking grades as 27% and decision letter is 60%. So implied utilization ratio is the demand on the task to demand divided by capacity. So that's the number that you see. So in this case, we obviously see that the bottleneck is contacting employers. So what we are trying to figure out here is, while there are multiple types of applications that go through this process, we want to know which of these stages is your bottleneck stage. So based upon the analysis that we did, the bottleneck stage is contacting employers, right? And that's the idea. So this is how we calculate the bottleneck and capacity utilization when you have a single flow unit, and you also what you do when you have multiple flow units, right? And I'm going to end this video here. It's already gone on for too long. But this is the basic idea of how you evaluate process analysis. So the most important thing in evaluating process analysis is capacity. How do you evaluate capacity? We looked at capacity, we looked at utilization, implied utilization, and we looked at all of these different vocabulary words within process analysis. It's important to understand all of these. All right. I'll see you all in the next video. Take care.